morning, Alabama! Hey, boys and girls, this is Mr. Brown. Today we're going to talk about combining like terms. Combining like terms, also known as evaluating algebraic expressions. But before we start actually evaluating algebraic expressions, we need to get our terminology right. So let's take some notes. Okay, so when combining like terms or evaluating algebraic expressions, the first thing we need to know is what are terms, what is an algebraic expression. An algebraic expression is a mathematical sentence with variables and operations. There may or may not be numbers involved, but you got to have more than one variable and you got to have at least one operation. So what I have given you here, 7x plus 9y minus 15, is an algebraic expression. It's not an equation because there's not an equal sign. It is an algebraic expression. All right, in this algebraic expression, there are three terms. A term can be just a number by itself. It can be just a variable by itself. Or it can be the product of a number and a variable. And one of the things we have to be very careful about with our terms is that we include the symbol in front of it. All right, so for example, in this algebraic expression, there are three terms. One of the terms is 7x. One of the terms is 9y. And the other term is not 15, it's negative 15. Those are the three terms in this algebraic expression. All right, next up, what is a coefficient? A coefficient is a number multiplied by a variable. In an algebraic expression. Okay, so when you see the 7x, the 7 is called a coefficient. All right, so up here in this algebraic expression, I have two coefficients. They are the 7 and the 9. Okay, the x and the y are the variables. The 7 and the 9 are the coefficients. So what about this negative 15? This negative 15 that doesn't have a variable with it is called a constant. So a constant is a number by itself. So again, in this algebraic expression, the term negative 15 is a constant. And all of this will become important as we go along. You'll just wait and see. So, what are like terms? Like terms are terms that have the same variable and those variables need to be raised to the same power. Remember, the power is the exponent. So I'm going to give you some examples of like terms, things that are like terms, things that are not like terms, and we're going to tell why the things that are unlike terms are unlike terms. So an example of like terms. What about 3x and 2x? Those are like terms. They have the same variable raised to the same power. Now, what is the power there? What is the exponent with that x? Well, if you've got just a variable, there is an understood first power on it. Okay? So this is like 3x to the first power and 2x to the first power. All right? Why are these not like terms? 5x squared and 2x. Well, they're not like terms because they're raised to different powers. They're the same variable, but they're raised to different powers. So those are not like terms. Now notice that the coefficient doesn't have to be the same. The 3 and the 2 are not the same, but those are still like terms. What about w and w divided by 7? Well, those are like terms because they have the same variable raised to the same power. What about 6a and 6b? Why are those unlike terms? Well, they got different variables. The variables are raised to the same power, but the variables are different. Okay? Another thing that you need to pay attention to is constants. Constants are like terms as well. So what about the number 5 and 1 and 8/10? Well, they have the same variable in that they're both missing their variable. They're just constants. So both constants, shh, that's our little secret too. Those are like terms. What about 3 and 2/10 and n? No. One is a constant, one is a variable. They don't have the same variable raised to the same power. Lastly, what about 6 and 6 squared? All right, are those like terms? Well, 6 squared is 36, right? And 6 and 36 are both constants. So even though this has an exponent that's different from this one, this is an understood 1, they're like terms because they're both constants. All right, now let's get a list of terms and make sure that we can identify which ones are like terms. All right, so let's look at a list of terms and see if we can identify which ones are like terms. In list number 1, we have 5a, t divided by 2, 3y squared, 7t, x squared, 4z, k, 4.5y squared, 2t, and 2/3 a. Remember, for them to be like terms, they need the same variable raised to the same power. So let's start with this first one, 5a. Are there any other ones that have an a raised to the first power? Well, 2/3 a is one. So 5a and 2/3 a are like terms. Okay? What about the t divided by 2? All right, are there any other t terms? Well, we've got a 7t and we've got a 2t. So all three of those are like terms. All right, what about this 3y squared? We got 3y squared, but there's also a 4.5y squared. So those are like terms as well. All right. Now, what about this x squared, this 4z, and this k? Well, it's like people going to the dance without a date. They're going stag. They're by themselves. They don't need a date. They don't need somebody to hold their hand the whole time and sit awkwardly at the table instead of dancing together. They're just going to go by themselves, and that's okay. So we have several different groups of like terms, but these don't have any terms that are like them. All right, number 2, 6b, c, b, 17, 4b, 32, and 17b. All right, let's start with the b's. We got a 6b. We've got a b just by itself. We've got a 4b. And we've got a 17b. All 4 of those terms are like terms. All right, what about this c? Are there any like terms with this c? No. Just go into the dance by itself, and that's okay. He's going to have a good time. And then what about the 17 and 32? Well, if you remember what we said earlier, constants are also like terms. So 17 and 32 are like terms as well. All right, remember again, not only do they have to have the same variable, but the variable needs to be raised to the same power. So let's look at this one. All right, do the x's and the x squareds go together? No, they're not like terms. All right, but what about this x and this 3x? They're like terms. All right, what about this x squared and this 3x squared? They're also like terms. All right, and then what about 3 and 6 to the second power? Well, those are both constants. They don't have a variable, so they are also like terms. So I'm sure the question on everybody's mind is, why do we need to be able to tell which ones are like terms? Well, to evaluate an algebraic expression, we have to combine the like terms. And if we combine things that aren't supposed to go together, it just doesn't work out. Let me show you an example down here. Let's say I've got a handful of M&Ms, and I have another handful of M&Ms here. And being the obsessive compulsive person that I am, I like to eat the colors together. All right? Because everybody knows the blue M&Ms and the orange M&Ms and the red M&Ms, they all taste different. So let's say that my blue M&Ms are X and my orange M&Ms are Y. Well, over here, I have 3 blue M&Ms, so I have 3X. And I've got 3 orange M&Ms, so that would be 3Y. Well, over here, I have 2 more blues, so 2X. And over here, I have 5 more oranges, so 5Y. Well, if I combine the like terms, if I take my 3X and I add to it 2X, then I have 5X. And if I take my 3Y and add my 5Y, now I have 8Y, right? Can I put all these together and say that I have 13XY? No, because again, the blue M&Ms taste different from the oranges, so you want to eat them separately. So I have 5X plus I have 8Y. Get it? Good. So again, why did we learn which ones are like terms? Because if we want to simplify an algebraic expression, what we need to do is combine the like terms. All right, so think back to the M&Ms. How did we combine the like terms? We had our x's, we had our y's. Well, to combine the like terms that have variables, all you have to do is add or subtract the coefficient. That's the number in front of the variable. All right, so here we go. The instructions say simplify. Simplify means combine any like terms that you can, simplify, put things together. So for number 4, we've got 7x plus 2x. They have the same variable raised to the same power, so we can combine them. And all you do is add or subtract the coefficient. Well, how do you know if you're supposed to add or subtract? Well, it says plus. This one says minus. Now this is a negative and we're adding to it, so we're going to have to pay attention to our positives and negatives like we always do. So number 4, 7x plus 2x. Those are like terms, so we add their coefficients. That would give me 9x. Now, can you solve for x? No, because there is no equal sign. Okay, so that's our answer. We simplified it. Number 5, 15a minus 5a. Those are the same variable raised to the same power. 15 minus 5 is 10, so that would be 10a. Number 6, negative 5x plus 9x. Those are like terms. They have the same variable raised to the same power. We've got a negative 5 plus 9. Same sign, add and keep. Different sign, subtract. Keep the sign of the larger number, and then you'll be exact. There were more positives than there were negatives, so it's positive 4x. Number 7, 10b minus 9b. Well, 10 minus 9 is 1, so this would be 1b. But when you're using variables, if your coefficient is 1, you don't put it. You just put b. Okay, there is an understood 1 in front of it. All right, same sort of principle with number 8. I've got 9g minus g. Well, what is the coefficient in front of this g? It's a negative 1. Okay, because there was a minus sign in front of it. So 9g minus 1g would be 8g. Number 9, 10b minus 15b. Well, 10 minus 15 gives me negative 5b. Yes, you can wind up with negative terms. All right, number 10 says 6b plus 2a minus 3b plus 4a. All right, can I just put all of these together? No, because they're not all like terms. So let's identify the like terms using different shapes. All right, this 6b, I'm going to put a circle around it. What could combine with that 6b? Right, the negative 3b. Because they have the same variable raised to the same power. Well, what about, I'm going to use a square this time. What about this positive 2a and this positive 4a? Those could go together. So I'm going to combine the ones that go together. 6b minus 3b would leave 3b. Positive 2a plus 4a would leave positive 6a. Now, let's talk about some rules for your final answer. The number 1 rule with algebraic expressions, as far as your answer goes, is the variables need to be in alphabetical order. So even though this is what it simplifies to, I'm going to do some rearranging because the variables need to be in alphabetical. So the positive 6a needs to be first, and the positive 3b needs to be second. Your variables should be in alphabetical order when you're done. Okay? Number 11, 3m minus 9n plus 4m plus n plus 14. Are all of those like terms? No. So let's find the ones that are. All right, is there anybody for the 3m to go to the dance with? Yeah, this positive 4m. All right, what about this negative 9n? Does it have a date? It does, this positive n. And what about this poor little plus 14? It doesn't have any like terms. So we're just going to bring it back down. Now, that positive 14 is a what? It's a constant. That leads us to rule number 3. Rule number 3, constants always go last. Okay, so when I bring this down, the plus 14 needs to be the last thing because it was the constant. Now, let's go ahead and think. If our variables need to be in alphabetical order, should I start by combining the m's or the n's? M comes before n in the alphabet, so let's start with the m's so we don't have to rearrange it at the end. 3m plus 4m is 7m. All right, so I used those up. I used that one up. Negative 9n plus 1n. Well, negative 9 plus 1 is negative 8. So this would be negative 8n. So 7m minus 8n plus 14 is our answer. The variables are in alphabetical order, and the constant is last. All right, look at number 12. Do you notice anything about number 12? Are there any like terms? There are not. So what do? Well, we just bring it down. That's our answer. The only thing that is keeping me from writing this as my answer is the fact that P does not come before B alphabetically. So I do need to rearrange it. So I'm going to bring this positive 9B up front. And you might think because there was a plus here, you need a plus here. But look at what you're about to move. It's a negative 8P. So when I bring it back here, the negative becomes the minus 8P. So no, there were not any like terms to combine, but there was some rearranging that we needed to do. All right, number 13, 5x cubed plus 3y plus 7x cubed minus 2y minus 4x squared. All right, which ones of these are like terms? Well, the 5x cubed and the positive 7x cubed go together. Make sure you get the sign in front of it. The positive 3y and the negative 2y go together. And then again, this little minus 4x squared, it doesn't have a like term. All right, so we got to pay attention to alphabetical. So the x's need to come before the y's. But what about this x has a cubed and this x has a squared? Where those are not like terms, which one's supposed to come first? Okay, your number one priority is alphabetical. The second thing that you need to pay attention to is exponents must be in descending order. That means you start with your biggest exponent first. So the biggest x that we have is this cubed. So 5x cubed plus 7x cubed would be 12x cubed. And we stick with the x's before we switch to y. So we need this minus 4x squared. And then lastly, then we can move over to the y's. 3y minus 2y would leave 1y. So just plus y. Again, we don't need that 1 in front of it. Are you starting to get the hang of it? Good. All right, we're going to do a couple more that involve the distributive property. This is just one more layer of difficulty to the problem, but we can handle it. But real quickly, let's review the rules for your final answer. Number 1, the variables have to be in alphabetical order. Number 2, if there are the same variable with different exponents, we are going to list those exponents in descending order. That means you start with the biggest exponent for that variable and then move down to that variable's done, and then you move on alphabetically. And lastly, if there is a constant, the constant is always listed last. Let's look at these next few problems. Number 14 says 2 times the quantity a plus 2a squared plus 2b. What makes this one different is that we have this number right outside of some parentheses, which doesn't mean that you multiply 2 times a. You have to distribute the 2 to everything inside of the parentheses. So not only are we going to multiply 2 times a, but we're going to multiply 2 times a positive 2a squared. All right, so that's going to give us 2 new terms. So 2 times a is 2a. Positive 2 times positive 2a squared would be positive 4a squared. And then this plus 2b was not a part of the parentheses, so it doesn't get multiplied by 2. We just bring it down. So plus 2b. Now that we have distributed, we need to figure out if any of these things are like terms. Are they? No, right? So the last thing we need to worry about is putting them in the right order. Okay, A comes before B in the alphabet, so these A ones need to come first, but which one needs to come very first? You start with the biggest exponent. So we need the positive 4a squared first, then the positive 2a, and then we can move on to a different letter, so plus 2b. So once we distributed, we had the right answer, it was just in the wrong order. Number 15, 5c plus 4c squared minus 2c. Of those, are any of them like terms? Yes, the 5c, and again, make sure you get the symbol in front of it. The negative 2c are like terms, and the positive 4c squared doesn't have anybody, right? But which one should happen first? All right, we got c and we got c squared. You want to start with your biggest exponent. So the first one should be the positive 4c squared. And then 5c minus 2c would leave positive 3c. Number 16. Right, we have a number outside of parentheses, which means we have to distribute. Now this one has a lot of things that it needs to be distributed to. Every single thing inside this parentheses needs to be multiplied by 3. This is called the distributive property. Okay, you are distributing the multiplication to everything inside. So 3 times p is 3p. 3 times positive 9q would be positive 27q. 3 times a negative 2 would be negative 6. And 3 times a positive 9 would be positive 27. And then again, this plus 14p was not in parentheses, so it doesn't get multiplied by 3. It just gets brought down. All right? Now, which one of these should be first? All right, we got p's, we got q's, and we got constants. Remember, the constants go together. Well, p comes before q. So we're going to put 3p plus 14p together. That would give us 17p. All right, next up would be the q's because the constants go last. So we need to bring down this positive 27q. And then lastly, negative 6 plus 27 would be positive 21. 21. All right, so there's our answer. Are they in alphabetical order? Is the constant last? Good. Number 17. 18 minus 2b minus 6a plus 6b. You'll notice that there are parentheses. And just outside the parentheses is a negative sign. So what you're going to do is distribute this negative. So since this 2b was positive, when I give it a negative, it's negative 2b. Now, when I distribute the negative to the negative 6a, a negative times a negative makes a positive 6a, and then bring down your plus 6b. The a's go together. 8a plus 6a would make 14a. Negative 2b plus 6b would make a positive 4b. All right, one more, and then there's one other little skill I want us to pick up before we leave the notes today. Number 18, 2 times the quantity a squared plus 2b plus 2a squared plus b plus a. So we're going to distribute this 2 to everything inside the parentheses. Okay, so 2 times a squared would be 2a squared. 2 times a positive 2b would be positive 4b. 2 times a positive 2a squared would be positive 4a squared. Bring down your plus b and your plus a. All right, 2a squared and positive 4a squared are like terms. Positive 4b and positive b are like terms, and then the plus a just by itself. All right, so we'd start with the a's, and we'd start with the a's with the biggest exponents. So 2a squared plus 4a squared is 6a squared. Positive 4b plus, remember this is an understood 1b, would make positive 5b plus a. Uh-oh, Mr. Brown made a mistake. We can fix it though. Shh, it'll be our little secret. We don't make mistakes, just happy little accidents. What is the mistake here? Well, I did the B before I finished with all of the A's. That's not alphabetical. So the 6A squared was fine. But I need to bring this positive A up, and I need to push the positive 5B back. All right? There's one other skill that I want us to learn using these skills and some other skills that we've talked about in class. All right, lastly, we need to connect these ideas to some other prior math knowledge. For example, the instructions here read, write an expression for the perimeter of the rectangle, then simplify the expression. Remember, anytime you see the word then in your instructions, there's something to do before and after. All right, so how do you find the perimeter of a rectangle? Remember, to find the perimeter of any polygon, all you have to do is add the sides together. So we're going to add the top, which is B, plus the side, which is H, plus the bottom, which is B, plus the other side, which is H. So write an expression for the perimeter of the rectangle. Done. Then simplify the expression. All right, what of this could be simplified? What of this could be combined? Well, b plus b, 1b plus 1b is 2b, and h plus h, 1h plus 1h is 2h. So there is a simplified expression for the perimeter of this rectangle. Now this one is a little bit more involved, but it's the same concept. First of all, remember that if you're going to find the perimeter, we want to make sure we label all of the sides. Or we could use the formula for a rectangle, which was 2 times the length plus 2 times the width. All right, so doesn't matter which one's the length and which one is the width. I just normally use the longer one for the length. So we're going to do 2 times 4x plus 1. That's 2 times the length plus 2 times 3y minus 3. That's 2 times the width. So this requires us to remember the distributive property. So we're going to multiply both of these things by 2 and both of these things by 2. All right, what we got there is 2 times 4x is 8x. 2 times a positive 1 is positive 2, plus 2 times 3y is 6y, and 2 times a negative 3 would be negative 6. All right, so there's an expression for the perimeter. However, it is not simplified. All right, so will anything combine with the 8x? No. So bring down the 8x. Will anything combine with this positive 6y? No. So plus 6y. The only things that would combine would be this positive 2 and this negative 6. Positive 2 minus 6 would give you negative 4. So that is our answer, simplified, for the perimeter of this rectangle. All right, there you go. That was a lot of information today. Don't forget that you can always go back through the video and pause and re-listen to instructions if you have questions. Tomorrow in our Google Classroom, there will be some review questions based on today's information. I will post the review questions and an answer key. Don't cheat. All right. You need to print out and work out the questions on your own first, and then use the answer key just to check and make sure your concepts are what they're supposed to be, that you got the right idea. Don't forget that Friday will be our first minor grade. It will be through Google Classroom. It will be on order of operations and combining like terms. So your PEMDAS and your evaluating algebraic expressions. After this video, don't forget to answer the questionnaire about the video. Don't forget to like, comment, and subscribe. Ring that little bell so that you know anytime a new video pops out. Hey, you guys stay safe and don't do drugs.